Right, this one here will be the first speed controller that we're going to test. Unfortunately, as soon as we took this out of the packet, we found that one of the solder joints on the wire was not done properly and it just fell off. So I'll need to fix that up first. Alright, so the first thing we did is just fix up this red wire, as that just fell off, as we said before. Now the other thing we noticed is that the wiring is the other way around, so we're not sure if this is going to operate in reverse. But as you can see here, we've got black, yellow, red. Here we've got red, black, yellow. And this is wound anti-clockwise, so is this. So in that position, it shouldn't run at all. So once you turn it that way, it cuts out the speed controller. So what we've got here is the first speed controller that we purchased, and as you can see here, we've got that set on 25% of pulse width modulation. That's given us an output of about 1,600 revs per minute, and we've got that, as you can see here, attached to the motor, and then we've got a pickup here which is going to the tacho. We're running that at about 24 volts, and we're going to test the other speed controllers that we got in, just to see if they're working. Alright, so what we have here is the second batch of speed controllers that we received from the supplier, and as you can see here, we've got that set at 25% pulse width modulation again. It's actually connected up all the same, and we're getting nothing happening with the motor itself. So as you can see there, that'll just go back to zero, and it's not driving the motor, and the motor is obviously not registering right the tacho. So what we're going to do now is try the other ones. This is obviously a dud one. We'll try the other ones and see how they go. Right, a couple of things have come to pass since we tested the first one of these. We've tested the other two, and we've got the same result. We get, we set it for 25%. You can see here we're getting no registration at all with the motor moving. If I move the motor, you can see that the pickup does work. And the other thing that we found is that we have a different wiring combination with reference to the control wires compared to the first one, but that may be reversed inside here, and they're wired around the other way, which I think is what they've actually done. Other than that, we've got 3 of these. 3 of them don't work out of that batch, and we've contacted the supplier and and told them the situation, and they're going to send out 3 more. Alright, so what we have here is the first of the replacements of that batch that didn't work, and we're just going to try that out now. So I'm going to set this for 25%. So I'll just get the controller, set that for 25, and now that should have the motor already working, and it's not driving properly. There's 26%, and as you can see here, we're getting nothing. The thing we did notice is that if we flick the motor, it started to work, but it wasn't driving at the proper revs per minute, which was about 1600 revs per minute. To actually achieve 1600, I'll just turn it up and see what we get. But we're definitely not getting the control that we got out of the first one. The first one was very accurate and very smooth. There's about 1600, close to what we had before. You can see we're up to 53% of pulse width modulation before we even get any control. The stop start does work, and if I put it back on again, it doesn't start the motor. You've got to physically turn the motor right to get it started. So it just doesn't have the current output to actually drive the motor properly. Once the motor starts turning, then starts to control it, but nowhere near as efficiently as the first one that we had sent out. So there's definitely a fault or a change in these that they've done, which is causing this problem. What we'll do is we'll take out another one and see if that has the same problem. So we've got the second one hooked up, and we basically got the same problem. We actually got this set to 60% at the moment because we were just playing around with it, trying to see what the difference was. At 54% it was actually running slower than the first one, but still didn't have the capability of driving the motor. If I stop it, even at 60%, so here we are, we stopped it, and if I go to start it again, right, the motor's not working. If I flick the motor, then it will start. Alright, now she's running up to, right, 2500, and I can just stop with my thumb. Doesn't do anything. It's got no torque, and certainly will be totally useless as far as a speed controller for a DC motor. Right, so this is number 3 of the replacement units for the ones that weren't working. As you can see here, we've got this set 25%. We're getting no readout. If I flick the motor, it'll start turning, but not at the proper speed, and no torque, but it'll turn. I'll increase it to 40%. As you can see here, it's still way under what it should be. If I take it up to 60%, which should be way faster than what we're getting here. Let's put it back up there because that's what we had the other one at when we showed you. 60%. Kind of around about the same figures, about 2,000 odd, but that should be way faster than 2,000 revs per minute. And I can stop it. It's got no torque. It will start up again, but it's useless as a controller for a DC motor because you need the torque, which the first one we got off the supplier worked perfectly and we had no issues with it at all. So that's why we put an order in for 3 extra ones which failed, and then the replacement ones that were sent out are working, but they don't have the drive right to to control the motor and control the torque of the motor at different pulse with modulation outputs. So you couldn't use it for any application that you require the motor to do any work. The controller is just not providing the current that's required for that. Alright, so we're back to the first one that was supplied, and what we have here is, as you can see, we've got 25%, which is about 1600 or thereabout revs per minute. Torque wise, I've got to put a lot of force on that to try to stop that motor. Right, so this particular unit is doing the job that it's supposed to do, and we'll do some comparisons in a minute. Now the interesting part is that this one works, and that's the original one. The 3 that were first sent out do not drive the motor at all. There is no output from the units, and they physically do not allow the motor to operate. The second one, the second batch, which they sent out as replacements for the first 3, will drive the motor, at least allowed to turn around, but certainly doesn't have the control that this one has, and has no torque. You can stop it very easily. You will see the difference here. So this is at 25%, right? Then we went up to 40%. So that's 40% on the original speed controller. That's at 2800 revs per minute, right? And as you can see here, it's very hard to try to stop that motor. That motor will actually do the job it's supposed to do. And the application we want to use it for, requires that. I also took it up to 60% on the other ones. see here at 60%, alright, just holding it off here because it's vibrating a bit, we're at 4,300 revs per minute, and you won't stop that. It slows it down a bit, current rate, draw goes up, but the point is that, it'll do the job it's supposed to do. If I switch that off, right, so now I'll switch the motor off using the controller or the speed controller on off switch. You can see the tacho has gone to 0. If I put that button back on instantly, right, it does the job it's supposed to do. I'll just turn that down because there's a lot of vibration. Put it back to 25%. So we've got it turning over. I think this is more of a case of buyer beware, and this is a good reason why you should test your products as soon as you get them to make sure they're operational. You only got a certain amount of warranty time, and if you fall out of that warranty time, then they've got an excuse to turn around and say, well, they can't help you. Whatever they've changed or whatever they've done, they're either using inferior components, or they've changed something, or something's being done wrong in the assembly process, which is causing the other units to either not work at all or not work correctly.